Hello all, let's discuss about advanced driver assistance system. So here we have an ADAS. ADAS will require number of sensory networks like it could be camera, radar, which is short and long, and we have a lidar and ultrasonic. So all these sensory circuits are used for sensing the outer world for a vehicle better movement in a on road, or it could be in traffic or any scenario. So here let's just see what are the key features of ADAS. So here when you are collecting the data from different sensors to persist the surroundings, so it could be example cameras, radar, the lidar and ultrasonic sensor. So all this data is going to we are going to club together and apply some algorithm along with the timestamps so that we can see the surrounding environment or comprehend the view of surrounding environment. So this is one of the key point for or the key element where we need to tune our self-driving car or autonomous car, or it could be simple ADAS feature vehicle. So here we are having sensor fusion. So sensor fusion, we have a few algorithms which can help us to persist the surroundings using the number of sensory data. Mm, Then we have a real-time data processing. So it is responsible for data real time to to make a real time decisions. So we need to focus on real time data processing. So for adaptive cruise control, or it could be automatic braking, it's a highly key points or key applications that requires a lot of real time responses or a lot of real time processing. So in most of the ADAS feature development, we might use controller which can process this and with the high speed. It could be like Jetson Nano, or it could be Jacinto 7. All those controllers hardware we can use for real time data processing. And we have a control of actuators. So for your braking and throttle, also steering the wheel. So all these activities we need to perform. So whenever object is detected or whenever obstacle is detected, we need to stop the vehicle by act. If it is act to ADAS, so it should break the speed, or it should pull on the push on the brakes. For so it's a key point that we should control these actuators, which will help us to do some physical activity or output activity for us. It could be steering of a wheel, it could be braking, or indicating indicators, automatic indicators, as well as a few other things. So line departure warning, automatic braking, and we have this adaptive cruise control as well. So these are the features where this uh, sensor actuators will be coming into picture for steering control, the indicator control, the headlights, the so for detecting the obstacle. So when we use the camera to detect some obstacle, and we will confirm the distance from the camera to that object using lidar or ultrasonic, or even the radar sensor. So we can basically stop using a brake or steer the wheel, which is steering wheel. Also we can step on throttle for acceleration and deceleration. We have a safety redundancy. So ADAS ECU is often designed with built-in safety mechanism and redundancy to ensure the safe operation. Like we need to safely operate, or if you are braking from your side and the brake is failing, or the sensors are not working, or it could be some wiring problem. So there should be another way where this signal of braking speed should be going to the wheels. So for this, we can use something like alternative paths where we can transfer the signal. So, and also it should be safer that way, that if any physical damage happens, or it could be any electrical damage, it could be any interference, even though it should be fail safe. So we can say for ADAS ECU, there should be a feature for safety and redundancy. And we have autonomous features like depending on level of autonomous automation, the ADAS ECU might also play a role in a fully autonomous driving system or particular higher level. So we have levels from 0 to 5. So depending on which level we are at, so automation of a driving activity will be performed or segregated. Thank you.